Hi, I'm just making a quick video on how to go through the week 2B poll for the Unix-based questions in that poll. There was one common question was, what about the sequencing material? That's going to be mostly relegated to the next week's poll, just so that way we could focus on things that were going to help you the most with your homework at the time. So the first question that was content-based was which of the following would fail to create a file called log.txt, and the issue was a permission error. Well, the answer for that one would have been this one, and that's because the root folder, or / is, I should probably call it, although colloquially, people often refer to it as the root because it's like the root of the tree of directories that is the overall file system. As you might guess, that's really important, and so you don't have permission to write to it. I don't have permission to just write to it freely. I have to invoke special permissions. This one would work. This is just an absolute file path that would work from anywhere on your system because it writes to the home directory. This file would be created wherever your browser or your terminal currently is looking. Technically, it could have failed if you are inside of a directory you don't have write permission to, but you do have read permission to. In fact, I probably should add a little bit of clarification to this for future purpose. Assume that the directory you are in currently, you have permission to write to. That said, this is almost never going to work without some explicit effort on your part. And finally, this will also be true from this point of view, is that it turns out you don't have to actually specify the name of the file path in most operating systems based on Unix. So this are equivalent. It's just going to create it in the current directory. You have seen one example in this course where that's not true, and that's in the homework, where for a command that does not exist in the special command directory that you do not have permission to write to, you had to provide a file path in order to actually use it as a program. The next question was, which of the following would add lines of text to log.txt? I'm going to bold that, without overwriting its original contents. And so that means that you're going to be probably appending. Technically, you could prepend or even insert stuff in at a specific line. However, only one of these actually has the ability to just write to that file, and that is our double greater than symbols. This one would have overwritten the original file. This one wouldn't work. You can't pipe directly to a file. That's the pipe connects one command to another command. Finally, the colon doesn't actually connect commands inputs and outputs. It just allows you to write multiple commands consecutively. So all in one line, and then they get executed one after another. Very common for just kind of having some quick copy-pasting code, but this one would actually produce an error because that's not a command, and that's how Bash would interpret it. Just a standalone piece of text is going to end up trying to be interpreted as a command, which log.txt is not one. This next section, I'm going to jump through pretty quickly, but the question is basically saying, write a piece of code based upon this pseudocode that takes only the 5th line of text from the sequencing file pretend.fastq, which we're going to assume already exists. So that was actually part of the prompt. Assume you are in the same directory as both files and that the fastq file has at least 2 sequences. I'm going to just say already described because there was a couple of people who are just like, oh, let me wget that file. Well, I've already told you it exists at the beginning. So there's a lot of different ways you could do it. In fact, I had one just beautiful answer using a program called sed that is more explicitly designed to do something like this. It just can pull specific line numbers out of a file. Great answer. I don't know why you're watching this, you clearly know your stuff. But what's going on here is that I'm telling you to use one of these pseudocodes. So a command followed by an argument, followed by a file name, followed by an IO operator, an in and an out operator. So for example, pipe, greater than symbol, double greater than symbol. Those are all IO operators, in and out operators. I did go back and add that line of definition in there just to help you guys. That's probably not going to be on the test, like this definition, so you should just be aware of the different tools. Now, the reason why that works is that coming down here, I give you some more examples. So in this case, the pseudocode you should eventually have come up with, you've seen examples of in class, which, you know, I think y'all could have probably logicked through this, but here I take the head of the file ending at line 5, and then I pipe that output to the tail command, and then only use the first line from the bottom, which is that 5th line, writing that to log.txt without overwriting it. So in order to do that, you would need to pull the head out. This doesn't let me click very easily, so I'm not going to try to click inside of it. I would need to pull, I'll just go through what I've written into this answer. You would need to go through the head, then to tail, those would be your commands. The argument for head would be the first 5 lines. The argument for the tail would be the first line of that output of head. The input for head would be pretend.fastq. And the input for tail is that piped data. In fact, if you gave it a file name, it would try to pull data from that file name, but that would actually cause a problem. That's not what you want the input to be. And so that data from the pipe wouldn't have anywhere to go. It'd produce an error. You'd be confused. That's what's going on. The pipe become the output of the previous command that the pipe sends tail is its input. Finally, that all gets used with the append operator. So that's greater than symbol. And then we're writing the file name that is being written to, which is log.txt. This line of questioning asked you to identify which of the flags would be appropriate if I wanted to direct the program to utilize a text file containing the sequence IDs I wish to download, and noting that that's not what I want you to use in the homework. Well, the argument that does that is one called --fasta--filter-file, which limits protein and RNA sequence files to the specified ref-seq nucleotide and protein accessions included in the specified file. So you would place sequences of text that look like this one, probably separated line by line instead of by comma, like they should be for fasta-filter. You would place them into a file, which you would then describe by replacing the string. So that string is like a placeholder for the name of the file containing the sequences. Here, in fasta-filter, it's a placeholder for this long argument, which is given as an example. Finally, I think we're nearing the end. To move from directory 1 to 2, which are both nested inside of the home directory, as evidenced by this code right here, we could not just change directly from dir1 to dir2 because it's not inside of that directory. It's inside of the home directory. The / drive is the very base of the file system, and it doesn't contain a directory called dir2. That's a completely different place in the file system. This is an absolute path to dir2. That would definitely work. This one is not going to work because that would be saying from the current directory, which is dir1, go to dir2. So you can't go directly from one to the other. But you can go up one directory, that's .. then go down into dir2. So that one would work. This one also doesn't work, so we're currently in dir1. dir1 doesn't exist inside of dir1, so that would immediately fail. And certainly you can't even go deeper to get to dir2. Finally, this one says from the current directory, so from dir1, go up one directory. Okay, we're in the home directory. Go into dir1. Okay, we're back into dir1. This is a silly piece of code. Then go up one again. Okay, we're back into the home directory. And then go to dir2. That works. Finally, why would we want to look at the output of the top command when working on a shared computer system? It's because it allows us to view how system resources are being used. And that's its explicit purpose. It's not to view the beginning of the file, that's head. To change the order of files, that would probably be move, but that would actually be moving from one directory to another. I don't know what this would mean. The order of files isn't really a concept. They're usually sorted alphabetically when you print it, but that's not like an actual concept within the system. To move a file, you would use the mv command, typically. The rest of this, the only thing I wanted to say was chmod is how you made the file executable. And then I try to go on and explain why you also had provided a path. So hopefully that explained a little bit of confusion about number 5 and subsequent uses of data sets. So thank you, and I hope that helps.